Good morning, class. My name is Heydee Perez, and today I'm going to talk about the ionizing classifications. Okay, first we have the nature of ionizing. Ionizing radiation is the radiation with enough energy to remove an electron from the atom. When the electron is removed from the atom, it says that the atom is charged or ionized. Okay, then we have two types of ionizing radiation. We have electromagnetic and we have particulate. Okay, electromagnetic radiation is the result of electrical and magnetic forces that travels in a space at the speed of light. Okay, I'm going to talk about some forms of electromagnetic radiation, but first we have to know that this radiation differs in frequency, energy, and wavelengths. Okay, also we have to know that we have two types of ionizing radiation. We have non-ionizing and we have ionizing. Okay, some examples of non-ionizing is the visible light, like we have in this room. We have the ultrasound. We have the MRI. We have microwaves. We have sound waves. And some examples of ionizing. We have the ultraviolet light, which is the sunlight. We have X-rays, and we have the gamma rays. Okay, on the other hand, we have particulate radiation. Particulate radiation, as the word says, are atomic particles like electrons and protons, which carry a very high energy in form of kinetic energy or mass in motion. Okay, these particles does not travel in wave. These travel as particles of matter released from an unstable atom. We have alpha and beta particles that are related with us. Alpha particle is released by the nucleus of an atom, an unstable atom, and it contains 2 protons and 2 neutrons. This is very similar to helium nuclei. This particle is very devastating in tissue due to the weighting factor, also known as the quality factor. This particle is positive charge and it transfers a huge amount of radiation in the tissue in our body. So alpha particles is harmless in air because it only travels 5 centimeters and it can be stopped by a piece of paper. But this is the most dangerous one we have. We have beta particles also, and this is a high-speed electron emitted from an unstable atom. Beta particles travel between 10 to 100 centimeters and it can penetrate paper and aluminum but cannot penetrate lead. So this is still harmful and very dangerous, but lighter and smaller than alpha particle. Okay, now I'm going to talk about the sources of radiation. We have 2 sources of radiation. We have the natural background and we have the man-made. I choose here this chart to help you guys understand better this concept. Okay, natural background radiation. The ionizing radiation from natural background is always present in our life. Example of natural background is the cosmic rays. Okay, the cosmic rays are coming from the sun and the outer space, and this is produced by the interaction of the cosmic rays with the atom in the atmosphere. We have also the baryton, which is a gas that we inhale daily in our life. It's in the air. Here in the chart, you can observe that the baryton we receive 37%. Here we have the space background, which I'll tell you right now, is 5%. We have the internal, that is the radiation that we have inside our body, and this is the terrestrial background. Okay, also we have the man-made radiation, and this is the radiation that comes from the medical procedures. Okay, here in the chart we can observe that computer tomography, which is the CT, we receive 24% of radiation. Here, nuclear medicine, we receive 12, interventional fluoroscopy, 7, conventional radiography, which is X-rays, and fluoroscopy is 5, and consumer 2. And we have the other 2, which is occupational and industrial. On average, the doses of radiation we receive from diagnostic X-ray are much lower than the one that we receive from natural background. However, radiation therapy reaches the highest level than the natural background. But the difference between those two is that in radiation therapy, we only receive radiation in one area. So we receive this radiation in one spot for a period of time. Finally, I'm going to talk about the effects of radiation. We have two types of effects. We have somatic effects and genetic effects. Okay, somatic effects are the damage that affect all body parts except the gonads. Okay, radiation affect slow down the cell division and damage these cells, so it can affect his growth and development. So some effects on the tissue can cause, like in the skin, it can cause you a skin cancer or any disease. In the eyes, it can cause you cataracts, and in the bone marrow, anemia. Last, genetic effects affect the genes and chromosomes in future generations. And these affect directly the gonads. Genetic information is contained in the chromosomes of the germ cells. In the man, it's in the sperm, and in the woman, it's in the ovum. Genetic effects are due to damage to DNA molecule. When you're exposed to radiation, the two or more DNA molecules at the same time broken, and when they're trying to recombine, they doesn't do it in the previous order. So this phenomenon is called translocation. This can cause acute mutations or deformation. Okay guys, now that I have explained you everything about radiation, I hope that this presentation is helpful for you. And remember that the biggest source of radiation that we get is the sun. So always, always, always use sunblock when you go outside. So this concludes my presentation. Thank you.